In this video, we're going to look at the sum from k equals 0 to n of cosine of k theta, and the sum of k goes from 0 to n of sine k theta, so I just expanded that out. And we're going to first take a look at the sum from k equals 0 to n of e to the I k theta, so we can factor out, we can all raise it to the k power, so e to the I theta to the k power. There's a sum formula that the sum of k equals 0 to n of z to the k is 1 minus z to the n minus plus 1 over 1 minus z. So the next thing we're going to do is, so we plug that in, and we finally get 1 minus e to the I theta times n plus 1 over 1 minus e to the I theta. So there's a complex definition of sine theta, so that would be sine theta equals e to the I theta minus e to the minus I theta over 2i. And through manipulation, you can get 1 minus e to the I 2 theta. So this, you can get this term by itself. So we're going to plug in theta over 2 to make this 1 minus e to the I theta. And you see that over here. So we just want to replace that with that. And so we solve for it. So we get 1 minus e to the I theta equals negative 2i e to the I theta over 2 times sine of theta over 2. So then we plug in, instead of theta, we plug in theta times n plus 1, and we get this. All this. And so we plug all that stuff into this fraction. Plugging that in, you will get negative 2i on both top and bottom, so you can cancel these out. And e to the I theta times n plus 1 over 2 over e to the I theta over 2. Well, you can just factor out I theta over 2, and it'll be n plus 1 minus 1, so that would just be n. So e to the I n theta. I'm at this step. And this over this, you can just kind of leave it like that. You can simplify if you want to, but I'm just going to leave it like that for the rest of the problem. So finally, you get that the sum from k equals 0 to n of e to the I k theta is e to the I n theta over 2 times sine of theta times n plus 1 over 2 divided by sine theta over 2. So taking the real part, you get cosine. So taking the real part of this will give you cosine, and taking the imaginary part of this will give you sine. And you can drag the imaginary part into the sum because the sum is over real numbers or integers. So you get the sum of k equals 0 to n of cosine k theta is the real part of e to the I n theta times whatever we said before. And the same thing for the sine of k theta is the imaginary part times whatever we said before. This would be n. So the next thing is, so we can replace the real part of e to the I n theta over 2 with cosine. Just the way Euler's formula works. So that would be e to the I theta is cosine theta plus I sine theta. So if you take the real part of e to the I theta, well, the real part would just be cosine theta, and the imaginary part would be sine theta. So we got cosine n theta over 2 and sine of n theta over 2 from this and this. And that is basically the video.